Hello everyone, welcome to Explorer Hop. For this example, we're told to integrate the following function, 2x plus 1 over x squared minus 7x plus 12. We can see that it is very difficult to integrate this rational function directly. Also, we can't use long division here because the degree of the numerator is less than the degree of the denominator. So to make it easier to integrate, we can decompose this rational function into partial fractions. And before we do that, to make our function easier to work with, let's first factor the denominator. So we get that 2x plus 1 over x squared minus 7x plus 12 is equal to 2x plus 1 over x minus 3 times x minus 4. Now, we will set up the following equation, where this is equal to a over x minus 3 plus b over x minus 4. And multiplying both sides by x minus 3 times x minus 4 gives us 2x plus 1 is equal to a times x minus 4 plus b times x minus 3. And now we sub in each of the roots to solve for a and b. Let's first sub in x equals 3 to find a. So this gives us 2 times 3 plus 1 is equal to a times 3 minus 4 plus b times 3 minus 3, which is 0. So 7 is equal to negative a, which means that a is equal to negative 7. Now we sub in the other root, x equals 4, to find b. And we get 2 times 4 plus 1 equals a times 0 plus b times 4 minus 3, which is 1. And this means that b is equal to 9. And subbing a equals negative 7 and b equals 9 back in, we get that 2x plus 1 over x minus 3 times x minus 4 is equal to negative 7 over x minus 3 plus 9 over x minus 4. And this gives us the partial fraction decomposition of our rational function. Now we can go ahead and integrate our function. So the integral of 2x plus 1 over x minus 3 times x minus 4 is equal to the integral of negative 7 over x minus 3 plus 9 over x minus 4 dx. And applying the sum/difference rule and constant multiple rule, we get that this is equal to negative 7 times the integral of 1 over x minus 3 plus 9 times the integral of 1 over x minus 4. Now we apply the method of substitution to each integral. So for the integral of 1 over x minus 3 dx, we can let u be equal to x minus 3, which means that du is equal to dx. And this means that the integral of 1 over x minus 3 dx is equal to the integral of 1 over u du, which is equal to ln of the absolute value of u plus some constant c. And subbing back in u equals x minus 3, this is equal to ln of the absolute value of x minus 3 plus some constant c. And for the integral of 1 over x minus 4 dx, we can let v be equal to x minus 4, which means that dv is equal to dx. So the integral of 1 over x minus 4 dx is equal to the integral of 1 over v dv, which is equal to ln of the absolute value of v plus some constant c. And if we sub back in v equals x minus 4, this is equal to ln of the absolute value of x minus 4 plus some constant c. Putting everything together now, we get that the integral of 2x plus 1 over x minus 3 times x minus 4 dx, which we already know is equal to negative 7 times the integral of 1 over x minus 3 dx plus 9 times the integral of 1 over x minus 4 dx. And this is equal to negative 7 times the integral of 1 over x minus 3, which we already know is equal to ln of the absolute value of x minus 3 plus 9 times the integral of 1 over x minus 4, which we already know is ln of the absolute value of x minus 4. Then plus some constant c. And that's it for this example. Thank you for joining us. See you in the next lesson.